All right. Good morning. Good morning. Hope everyone is there. Hope everyone had a great weekend. We're live. Computer is working, but a little slow today, so I apologize. Trying to save a file. There's two of you here. Good morning. Good morning. Good morning. Good morning. Okay, so the solutions to the homework are up. There are two of you here now. Hopefully more of you appear. Yes, more of you are coming. So welcome, welcome. So let's make sure that let's see, more of you are appearing. Good, good. Hey, Leanna, good morning. How are you? Good morning, Sarah. I think just the two of you are here. So I posted the solutions to the homework that I assigned for the weekend. Can you go over 23 and 25? Well, let's see if the board is working first. Hold on. Let's test the board. Let's see if this works. Hey, Cindy, good morning. I hope you liked my Monday morning GIF, whatever you call it. The board is operational. If you see it, please click on it and tell me what appears or write or type in what appears. Oh, that's right, Sarah. That is right. That's what it's about these days. That's what make the days a little bit easier. So I'm looking forward to reading what you guys say about your favorite movies or your favorite series. And I shared mine. And actually, it's probably one of the few times that I looked at the recommendations that Netflix makes. Like I think they have like a top 10, and yeah, they had this show on there called Money Heist. And if you haven't seen it, it's pretty interesting. Like apparently, like the whole world knew about the show, and I just learned about it 2 weeks ago. So yeah, I'm a little bit late. But let's see. Liana wants to go over 23. I have to look at 23. And we'll talk about the project at the end of this. There's only 6 of you here. Where is everyone? Getting out of bed? Hold on, just give me 1 second. Okay. Hey, good morning, Kyle. Good morning, Gianni. All right, so let's see. I'm just pulling up the homework. I'm sorry, my computer's running a little bit slow. Okay, here we go. So we'll look at 23. We're on the whiteboard. Let's see what's up here. 23. Okay. So we want to write this as a single logarithm, right? So we have to apply some rules here. So we look at 23. I hope you see this. I am now on the whiteboard. I'm not looking at our chat. So we have 6 log base 3 of x plus 2 log base 3 of 11. So, sorry for the handwriting. So I'm going to identify the factors here. So 2 and 6. So in the left-hand side of this expression, so this term with 6 times log base 3 of x, don't forget that this was detached because of the power property. So I'm going to rewrite this as log base 3 of x to the 6th power plus log base 3 raised to the power of 2. Okay, so what we're going to do is the following. So now we know that since we're adding, right? So since we're adding, we have to, again, when we have a single logarithm, so notice here that the base is the same. So we have log base 3, log base 3. So what we're going to do is we're going to write that as one logarithm. Hold on, let me get rid of the x. So the single logarithm that we have, right? So when we're adding, according to the rule, we're multiplying. Right? We're going to be multiplying exactly what the logarithm is that we're taking. So in other words, log base 3 of, right? So in this case, the of is this, which I will circle. So we have x to the 6th and 11 raised to the power of 2. So what we could do is we could write this as x to the 6 times 11 squared. But if you notice the solutions, to 23, so again, what should be present in front of you is the following. X to the 6 times 11 squared. The solution has 121. So the reason being is because 11 squared is 121. So we have log base 3 of 121 x to the 6th power. So that should be the final answer. Now let me go back to the chat for 1 second. Good morning, Zabe. So is that clear, Leanna, the explanation? So again, I have the homework solutions from the homework that I was assigned over the weekend. I just went over 23 because that was requested, and I'm hoping that's clear. Any questions so far? Good morning, Josh. So Leanna, did that answer your question with 23? 25 is kind of the same approach. 25 is the same approach. The only difference is that when you're subtracting, there's going to be a division. And since the base of the logarithm is the same, you can express it as a single logarithm. So was that clear? Let me go back. Leanna. No comments yet. So again, there is some delay here. So I'm hoping that this was clear, Leanna. Do you still need me to go over 25? Yes, great. Do you also want me to go over 25? Because if you understood how this one worked, then 25 is essentially the same. And number 11. All right, I'll go over one more. Number 11. What's up with 11? Okay, so we have to expand the logarithm, so I'll do this one quickly. Okay. So we're expanding. We're looking at number 11. Okay, we have log base 5. Sorry for the handwriting. log base 5 of the square root of x to the 5th power times y. So remember, we can rewrite the square root as log base 5, all of this raised, right, to the power of half. But if we're raising this to the power of half, then I could take this half and apply the power rule, and now we're going to make it half log base 5, right, of x to the 5th power times y. But if we're multiplying what's inside the parentheses, then we have to add that. But here's the thing. Half is applying, so this is what you need to be aware of before you start doing anything. You're taking half of this whole thing in here. So I'm going to rewrite half. And since we are multiplying within these parentheses, then we're going to add. But something that you have to be careful with is that you have log base 5 of x to the 5th power plus log base 5 of y. But since we have 5, or x is raised to the 5th power, we have to apply the power rule again and bring this here. So in rewriting all of this, we'll have a final answer as follows. Half times 5 log base 5 of x plus log base 5 of y. I hope that was clear. Was that good, Kyle? Sorry for the noise. I'm just getting my charger, my Rolly charger, or that, winder that I have for the charger. I had to get it. I don't have anyone reminding me that my battery is low, so now my computer's screaming at me. The battery is low. So let's see. Let's look. All right. Good, Kyle. Very good. So welcome, everyone. So we've gone over some homework questions. The solutions are there. Hopefully you took a picture of it, screenshot, whatever it is that you do. Also, we'll talk about the project at the very end of the class. Hopefully it's complete by now. Again, you were given an extension. It was originally due on Friday, and it's due tonight or at 11:59, right before midnight. So you have all day if you still need to tweak anything. So it was, really understanding of, the weekend, it was a holiday. I get it. So if there's like any other issue that you may have, please just, let me know, send me a message, and, we'll try to, or I'll try to accommodate you the best that I can. So hopefully you responded, you left your attendance. I'm really curious to read what your favorite movies are or what your favorite show is right now. I mentioned in the comment section that I'm kind of binging on this show called Money Heist. It's incredible. I don't know, it's just something about it. It just struck a chord with me. Just great acting. At the end of the day, that's really the secret, right, to anything. Talent. So let's move along. All right. So let's see. So we're looking now at evaluating logarithms and solving. So we're going to evaluate some logarithms and we're going to solve logarithmic slash exponential equations. So what bad joke do we have today? People have 10 fingers and 10 toes. It makes sense to use log base 10. So I think we probably spoke about this. So the long and short of it, log, if you just see log written by itself, the base is implied to be 10. And now here we have something called ln, which is called a natural log, and we'll talk about that. And the joke is that this natural log is saying naturally, with the letter E there. Very bad. If you remember earlier in this semester, I had like a graph It's something about math jokes and the quality of the math joke and the number of people that actually understand math jokes, and then there was like a random like spider or like some insect. Anyway, I assure you it's in one of your other chapters. So if you want to chuckle or if you want to just shake your head and put your hand on your forehead, you can do that. So anyway, so common logarithms. So as mentioned before, log base or log without a base. So if it just says log x, it's implied to be a base of 10. So common logarithms. So a calculator with a log key can be used to find the base 10 logarithm of any positive number. So if you do the following, if you have your calculator, you hit the log button, and you put in log, and let's say log 10 as an example. Log 10 should yield 1. But the question is why? Because log base 10 of 10, think of it that way. What power of 10 gives you 10? The power of 1, or 10 raised to the power of 1. You could try it. I mean, if you have your phone, you probably have your phone in your hand. I wonder how many of you are watching. I'm curious. How many of you are using your cell phone right now to stream or to listen to this, and then you have a laptop in front of you? I'm just curious. How many of you have been mostly using your cell phone to survive in this world? Oh, the silence feels like crickets, let me tell you. Oh my gosh. I guess the silence means no, because now in my current school, there's a large number of students that are using their cell phone basically to do all of their remote learning, which is cool as long as as long as you're doing it, right? At the end of the day, the device is kind of irrelevant, but cell phone's kind of limited. But I was just curious to see how many of you are using your cell phone to stream, maybe, and then you have like a laptop or a desktop to do everything else. I don't know. Maybe there's some of you that have two monitors. I have no idea. Anyway, moving along. So if we look now, you should have the handout. Let's go to the class work section. This should be in your learning materials. Let's see. I believe this should be not logarithmic functions. It will say, no, not properties of logarithms. Excuse me. It should say solving logarithmic and exponential equations at the top. So when you open today's handout, it should say, solving logarithmic and exponential equations. So that's the handout that we're looking at. And the first example would say log base 1000. So I'll look at that quickly here. I'm now on the whiteboard, and we're looking. So log base 1000. So in other words, no, sorry, not log base 1000, log 1000. So here, the log of 1000, but remember, it's log base 10. So don't forget, if you don't see the base there, it's base 10. Kind of like when you have a radical. A radical, right? If you just have the radical symbol, that implies base 2. So here, really, if you think about it, what power of 10 gives you 1000? So if we rewrite this in exponential form, it's really 10 to the x power is equal to 1000. I mean, if you wanted to, you could rewrite this so you have the same base. So you have 10 to the x, and again, you could raise 10 to some power to get 1000, and that power should be, let's see. I use my laptop for all my classes. Oh, thank you, Eleni. I hope you're not hearing that question right now. I asked the question like more than a minute or maybe 2 minutes ago. I hope the lag isn't that long, and if it is, I am so sorry. And just give me 1 second. Excuse me. So sorry about that. All right. Where were we? I'm so sorry. Okay, so if we're looking here, 10 to the x power, it will equal to 10 raised to the power of 3 because 10 cubed is 1,000. And in our rules of solving or rewriting exponents so that we can solve for a variable that's the exponent, remember, we have to have the same base. So in this case, x equals 3. But in your evaluation of log of 1,000, if you put that into the calculator, then you should have gotten 3. I hope you did. So log base, well, here the base isn't given, but again, if you want, you can get into the habit of writing log base 10. There's nothing wrong with that, but it's implied. So now here, this is where it gets a little bit tricky, because what power of 10 will give you 142? I mean, that's going to be really tough. Not possible to get an exact value or an integer value. So in this case, when you plug that into the calculator, you'll have an approximation. Clearly, it's greater than 100, so you know it's going to be at least 2 point something, right? But then if you go to 3, then it becomes 1,000. I have to show you this video as you're computing this. Someone shared with me their nephew, I think it's their nephew, 5 years old. I kid you not, 5 years old, and he's working in a notebook or a workbook, excuse me, on high school algebra, and he's trying to reason, or he's trying to approximate square roots. I'll show it to you one day. It's incredible. So we have to kind of get like at the or have the ability, excuse me, to kind of ballpark, right? Because 10 squared is 100, 10 cubed is 1,000. So if we do like definitely not 2.5, right? Because that'll be somewhere in the middle of 100 and 1,000. So if we do something like 2.1, then maybe that's closer to 142. So in this case, it is. So hopefully you found the other two here. So I'm going to give you the solutions here. To log base 1,000, or sorry, log base 10 of 1,000, log base 10 of 142, and log base 10 of 0.005832. So notice the negative power. So notice that. So that's kind of interesting. But at the same time, it shouldn't be too, what's the word I'm looking for? Too confusing. Shouldn't be too confusing only because if you raise something to a negative exponent, don't forget that. And if we look here, so again, back to the whiteboard. So anything raised to a negative exponent, for example, like 10 raised to the negative 1 power, it's going to become fractional, or 1 divided by 10. So something to think about. So again, most common logarithms that appear in calculations are approximations. So again, it'll be pretty specific, or I'll be pretty specific in regards to how you round. So if we look at the next set of examples, let's look here. We have what's called natural logarithms. So that was that bad joke that was made earlier. So we spoke about E. So E, again, this number that occurs in nature, right? We said it was about, what, 2.71, right? So when we looked at continuous compounding. So it's related to just, you can think about the idea of splitting. And I think a good way to do it, or to look at it, is a cell. And I used to show a video in class where there was this one person describing how a cell divides. So all you science buffs out there, I forget whether it's mitosis or meiosis, however you pronounce it. Someone in the chat will correct me, where a cell continuously divides. I'm waiting for it. I know there are a few of you. I don't want to call you out, but I know there's some future medical students out there. So please correct me gladly. I'll take it. So anyway, so the cell division process. And so that's an example of E, or basically this continuous, or this idea of continuous growth in nature. So that's why we call it a natural logarithm. So logarithms with base E are called natural logarithms since they occur in the life sciences and economics in natural situations that involve growth and decay. The base e logarithm of x is written natural, or ln of x. Or you can think of it this way too. So here I'm on my whiteboard. So if we have log base e of x, it's the same thing as a natural log. So that's basically what this is. So when you see natural log of x, or ln, on your calculators, it's really just a shortcut into saying log base e. So think of it that way. So for all positive numbers x, natural log of x equals log base e of x. So let's see here, another bad joke. I'm going to zoom in on this because this one I think you may like a little bit. And it's okay if you like it, you know, nothing to be embarrassed about. Who doesn't love a bad joke? Look at this, all natural and organic. Wow. I'm laughing more because I can only imagine like what your faces look like right now. I hope some of you are laughing, even if some of you are just like, man, this guy. Maybe some of you are thinking, wow, the quarantine is getting to Alarcon. Maybe. It might be. It might be. Look, I'm posting pictures. Think about it. I'm posting pictures of squirrels and birds in a bird bath. Life has definitely changed, but I'm trying to make the best of it. And I hope everyone is also. That's all we can be, is positive. All right, so if we look at number 2, now we have, again, evaluations here. So I want you to evaluate the following. This is more of you getting used to the calculator. So the challenge, if you have a TI-84, this is kind of no big, or not a big deal, because you can practice with it. If you don't, then you have your iPhone. So again, it's about flipping your iPhone to landscape and then exposing more features in the calculator that comes stock or equipped. So let me see here. Hold on, I'm looking at my iPhone now. Let's look. So my calculator. So here, do you have natural log? You do. So iPhone users, I'm sorry, Android. I'm sure you can figure it out. You can look for that, probably a little Google search. I have here my iPhone. And if you look at the number 4, when you're in landscape, you have log. Look at what the iPhone does, actually. It's interesting. So if you're with me and you're looking at your iPhone, to the left of 4, it has log with the base 10. That's interesting because if you have a TI-84, it'll just say log. So it's kind of nice that the iPhone is writing it in the proper form. It's like saying the square root. And it does. You see that? So iPhone users, you should look. You should be in awe that, let's say, the creators of Apple software, or the iPhone software, the iOS, they want you to really know that how a square root should look like with the number 2. Similarly with the cubic root, but that's kind of implied because, or not implied, but necessary if you have a cubic root. But in this case, they really are, bringing it to you that a square root should have the number 2 to indicate that it is the second root, excuse me. Similarly here, log base 10, they're just kind of reiterating that. And to the left of log base 10 is the natural log. So in your evaluation, and less talking from me, you should have found the following. So again, just evaluating, natural log of e to the 3rd power is 3. Another way to see that, if that doesn't make sense, I'll show you or prove it, for lack of better words. So remember, natural log of e, right? Or natural log of x, excuse me. So think of it this way, log base e of e, that's the question, right? Really, if we're rewriting this. And it's saying here, raised to the 3rd power. But if you have log, if the base is the same thing that is the end result, so in other words here, what I'm circling, if these are the same, what I've just circled, let me change the color. If these are the same, the end result should be 1. But if we apply the power rule, so then it becomes 3 times log base e of e. In other words, what power of e gives you e? 1. So in other words, this becomes 3 times 1, which is just 3. And the other answers are somewhat related to what we found in the previous section. So again, don't be discouraged with the negative number. That just means that you have the negative exponent and you're going to result or have a fractional value when you do that, when you raise a base to a negative exponent, usually. Okay, so some general properties here that we spoke about, some inverse properties. Remember, log base b of b, kind of like what we just went over here, log base e of e equaling to 1. So some of these you should try to remember. So this way they serve as a shortcut and you can just get to a response much quicker rather than having to convert from logarithm to exponential form. You'll just know the solution right away. So this is in your notes. You can screenshot it. You can refer to it at all times. Okay, so not to further complicate things, we have another theorem. Another theorem. So here's the issue. We're going to have different bases, right? So this may happen. So, or what we want to do is we want to change a base. So logarithms with other bases. So we can use a calculator to find the values of either natural logarithms base e or common logarithms base 10, excuse me. However, sometimes we must use logarithms with other bases. So we're able to change the base of logarithms using this theorem. So we're going to look at the theorem first. So according to this theorem, log base a of x, we can rewrite this as log base b. It's really irrelevant what the base is as long as the bases are the same. So in other words, log base a of x will equal to log base b of x divided by log base b of a. So in other words, it's like doing this. So I'm going to rewrite this here just to show you and highlight. I'm on the whiteboard. Log base a of x, that equals to log base b of x divided by log base b of a. So in other words, what we're doing here is basically looking at this, x and a are going to be divided, but not by themselves, but with a different logarithm. So the derivation or the rule for it is in front of you or right below. I don't really want to go too much into that because I think that it does create some confusion, but if you follow along, it's pretty clear. So again, there's just some conditions that are given. A to the x equals m. Log base b will then equal to a to the x power. So again, it's just rewriting. It's just rewriting some things here. And here we have log base b of m. So I wouldn't worry too much about the derivation, but if you follow along, it is mathematically sound. So I'll give you about a second just to look at that, to kind of process it, and then we'll move along. All right, so moving along. So in other words, before we move to the next part, there's a lot of things in math that they force to make something work. So again, if you look at the scenario here, there's some things that are forced to be, like for example, a to the x equals m. And then they're making log base b of a to the x. So some things are somewhat forced, but in forcing certain scenarios, then you're able to prove something like this change of base theorem. The application is much simpler, than the understanding of the derivation. So in other words, if we look at this next example here, we have a log. What is this? Log base 5 of 17. So here, if you have your TI-84, you're able to, I believe, let me look at the number. I think it's in math. Right, so my calculator is somewhat messed up right now. I believe it is in math, where you can change the base or you can select log, and then it'll give you the option to input a new base. But some of us may not have the technology. Some of us may just have our iPhone calculator or Android calculator, which is fine. But in that case, we could convert this here, this log base 5 of 17, into a different log or a log that has the same base when you're dividing. So what we need to do is just focus on these two numbers here. We're going to end up dividing them, 17 and 5, but we're going to attach a new base to it. And you can pick any base that you want, but for our conversation, we'll call it log 10 or log base 10, just because it's going to be easier for you to do it on your end. And the example that I have here is going to show you the natural log. So I'm curious, so if you do log base 17 divided by log base 5, will you get the same answer as if you did natural log of 17 divided by the natural log of 5? So I'm curious. So you should try that now. Let's see, hold on. I see Leanna's question. So Leanna says, on TI, if you press alpha window and then 5, you can change the base. Exactly. So thank you for that. Thank you. So the only issue is this. So some issues on my end, the TI doesn't work unless it's attached to a second monitor. I don't know why. It's confusing. But for those at home, if you have the TI, you can follow Leanna's instructions. For those of you who are using an iPhone or Android, the only difference is that you have to hit the number 17 first, and then the log button, or the natural log button. And then you'll have the evaluation. And then you divide that by 5, and then you hit the log button, enter, and then you'll have the evaluation, and then you hit enter again. So if you do this, whether it's through natural log or log base 10, you'll have the same answer. So similarly here, we have log base 2. So if we look at the next example, so here we have log base 2 of what is 0.1. This is going to be the same. Again, you can rewrite it with whatever base you want. We can do log base 10 if you want. We'll do natural log. So again, the focus is here. We highlight these two, and we essentially divide those, but we have to attach a logarithm to it, the same logarithm. So if we do that, we end up with this value, negative 3.3219 approximately. And we typically round to 4 decimal places, typically, unless otherwise noted. Oh, and here it's telling you to do that, so good. So I'm glad that I included that. So typically we would have time to try on our own, but again, this format is a little bit different. Maybe some of you already did. I know that I keep repeating myself and I apologize, but I guess that's what a good teacher does, right? So if you did move forward, the solutions are as follows. So you can take a picture of that and screenshot whatever it is that you do. So I'd love to move into the next section, but I can't rush that section. So this section was more about getting you acclimated or used to evaluating logs, rewriting them, knowing the difference between log base 10, a natural log, a log base E, all of these, differences between logarithms and how we can even change the base of a single logarithm so that we can evaluate it in an easier way. So, are there any questions before we wrap up today? Any questions with the project? So actually, I have a request. Although I posted the solution, not the solution, I'm sorry, the project in the classroom, I would like for you to share the file with me. And I want you to share it with me using this or giving access to this email address. So I need you to share, again, your project that's due today. I want you to share it to my email address, alarconmath@gmail.com. This way I can analyze it, I can provide feedback, and I can give you a grade. And then that grade I'll post, I suppose I can post it on Google Classroom, but it's definitely going to go in Jupyter. And I'll try to grade it by the end of the week. It's just kind of a crazy week. I feel like every week is crazy. Kind of goes without saying at this point, but I definitely want you to share your project with me. So you don't necessarily have to submit it. I mean, you can. Feel free. It may appear as late, but don't worry about it. It's not going to be late. I do need you, though, to share it with me before midnight tonight. If you share it with me like after midnight, like 12, 12:01, then it will be considered late. But if you share it completed, then you'll be okay. Are there any questions before we wrap up today? Any questions? Any questions before we wrap up today? So hopefully the extension gave you more than enough time. Hopefully the work was distributed equitably. And if you have any questions, I'll be around today to answer them. But I think for the most part, a lot of you are, you've progressed pretty well within the project, and many of you have finished. What about the 42 question homework? Let's see. I don't think we're up to that yet. Let me see. Hold on. Good question, Josh. So let's see. Let me look before we leave today. I will not give you 42 questions, that's for sure. Let me see. No, yeah, so this is not going to be the homework for tonight. Do I have it for the homework for tonight? Yeah, so I'm going to change that. So don't worry about that. I'll put something that's a little bit easier. It'll probably be more evaluating logarithms than this. So this, don't worry about. Tomorrow I'll assign it and I'll clarify the questions that you need to answer. Definitely not going to be 42. Definitely not going to be 20. Probably more like 10. I just have all of those there, so if you want to practice on your own, you can. So I'll give you more details tomorrow. But the homework for tonight will be different. All right. Any other questions? So let's see before we say goodbye. So again, I hope you posted the attendance for today. I look forward to seeing or reading what your favorite TV shows are, what your favorite series are. I shared mine with you. That's Money Heist. That's the series du jour for me. And that's about it for today. So don't forget, project, share it with me, and make sure that it's shared before midnight. On that note, have a great day, and stay tuned for the homework. I'll be sharing it at some point today. Have a good one, everyone.